Hi, Tao Pingali's Math Industry here, and today is New Year's Day, so this year it will be 2021! So, to celebrate that with math, we are going to talk about simple and easy pendulums, or also known as swinging objects, like you're swinging on a swing, like it's like swinging. The formula is time equals 2 pi, the square root of length divided that by gravity. The reason why we are going to review this is because of this. So this is the New Year's Eve ball drop, and that's the pendulum. We want to know how the time takes to get from here, there, and back. We want to know how long that pendulum goes. So many of these math symbols appeared in 8th grade and 7th grade math lessons. So we figured that today would be not a traditional holiday, but today would be a really cool cool math day because it is 2021. We're almost at the end of light of this COVID crisis, and yeah. The pendulum is what we're going to be focusing on today. So they wanted to know how long a pendulum in seconds, because that's time, to get from here to there and back. So, here's pi, which is also known as 3.14. That's a 2 right there. That is the square root symbol. That L means length. And that G means gravity. So, with the length, here is the length on the pendulum. We're measuring from here all the way down to here. And the gravity is the Earth pushing you down. So 9.81 meters per second squared is the gravity on Earth trying to push the object down. So here is the formula, but with numbers inserted into them. If 2 meters was the length right here of the pendulum shown in the video, well, on the TV screen, because in real life it would be much bigger, but in this scenario, it would be 2. So you see this 2 pi and this square root here? We have to divide that 2 by 9.81. to get our next step. Oh, and you can use a calculator for this. If you do 2 divided by 9.81, you'll be finding a decimal on this calculator, 0.204. But we're not done yet with this step because we still have the square root to deal with. So here's our next formula. We simplify it a bit for one step. So the thing is, to deal with that square root, we're going to have to use the calculator again and do the square root symbol again. So 0.204 square root. We get another decimal, which is 0.4516. We get 0.4516. So, since we got that square root symbol right there, we also have to deal with the 2 and the pi. So, we have to do 2 times pi, then 2 times 0.4516. So, 2 times pi, because pi is always 3.14. Pi cannot be any other number but 3.14. So 2 times 3.14, that would be 6.28. Then, we have to multiply that by 0.4516. We would get our answer in seconds because a time for a pendulum to move back and forth from point A to B and back is measured in seconds. So, if we do this equation right here, that is the number 6 right there, you will find your answer in seconds. The answer would be 2.831. But if you wanted to round it to like 1 decimal, it would take 2.8 seconds to get from point A to B and back. So that is our answer, 2.8 seconds. But what if we try changing that length to 4 instead? Let's try that on a different piece of paper. So, if we have the length as 4, and we have 9.81 here, square 2 awesome pie, that's so yummy, and here it is. So 4 divided by 9.81, we would get 0.408. But we still kind of have to deal with that square root. So go ahead and push that square root. Okay, we dealt with that square root. So on another piece of paper, we do the multiplying. So we do 2 times pi, which is 2 times 3.14. Then we get 6.28. But then we have to multiply it by 0.683. If we do that, you'll get an answer for time in seconds again. We can do that in a calculator. The answer would be 4 seconds and 28. Or we should say 4.3 seconds to round it if you want. So if the pendulum was 4 meters, it would be a longer seconds. So we notice that there is an indirect relationship. If you want a pendulum that is short, that pendulum speed will be fast, and it will complete a given amount of time from here to here in a short period of time. If you want a slower pendulum, the length is going to be longer, and that would mean that it would take longer to get from here to there. For the first problem, the short one, it was 2.8 seconds. But for the long one, we doubled it, and it was 4.30 seconds if we rounded it. So, the shorter the pendulum, the faster it goes. It's an indirect relationship. Thank you for watching Taoping Airlines Math Industry. Like and subscribe. To end the video, we're gonna watch the 2021 countdown for New Year's Eve. It's a countdown from 60 seconds. And there's the ball. 28, 27. Seven, 6, 5, 4, 3, 2, 1.